Hello, I'm Michael. Today we're going to look at the Pythagorean Theorem. Now, by way of motivation, first of all, if we are building a gate and we want to put a support board across the diagonal, about how long does a board need to be? We've got that drawn in the diagram. We've got the rectangle A by B, and there and there, and we've got the diagonal C. So to solve this problem, we could use the Pythagorean theorem, which says a squared plus b squared equals c squared. This theorem gives us the relationship between the sides of the right triangle. Now, how do we know this? Why is it true? There are many theorems to prove this, but we will look at one of them. Easy, convenient theorem. This was due to the ancient Chinese found on a manuscript from 400 AD or so, maybe 900 AD. There are many other proofs, one due to President Garfield, but we're going to look at this nice, elegant, easy one. Most people should be able to understand. Now, the ancient Chinese started out with two rectangles. They would have gotten this idea from dealing with origami, different shapes. So we start off with the two squares. We have a plus b on a side and a plus b on a side. Notice both squares are the same. They are both a plus b on a side. So, being squares, having the same dimensions, they have the same area. Area of square 1 equals the area of square 2. Now, the Chinese went on to, these individuals in particular, to divide the squares up into different parts. So on the left, we have 4 triangles, which I've numbered 1 through 4 in green, and we've got a square that's c by c. On the right, we've got the square of the same area, and we've divided this into parts also, but notice we have a smaller square that's a by a, and a smaller square b by b. And we have 4 triangles. Notice the triangles are a by b, a by b. They're all the same dimensions. So it's the same area as the 4 triangles over here. In fact, if you got a sheet of paper, cut out 2 squares of the same size, cut off triangles that are the same dimensions over here, those triangles could be made to overlap these triangles, showing that they're the same area. So what we have are 4 triangles on the left and a square C, 4 triangles on the right, a square A and a square B. But since the triangles are the same area, we could take them away, leaving us with square C equal to square A plus square B. Now if we rewrite that in terms of the area formula, c squared equals a squared plus b squared. And that is the Pythagorean theorem. So this is why it's true. You can replay this and review it as you need. Now if we work through this so you can see a quick example, a basic example of how it's used, let's put some numbers to this. So we've got a gate that's 6 feet by 8 feet, and we want a support board. We might need to cut some of the corners of the board off to fit as we want, just a little bit, but this will be about how long the board needs to be. So let me draw in the diagonal. I'll go ahead and draw it in green again. So this will be our support board right there. And I'll label that C, since we did that above. Now notice the important thing is that the letter that's alone in the equation is opposite the right angle. Whether you call it A, B, C, D, X, Y, Z, theta, gamma, whatever, the important thing to remember is that the number that's alone on one side of the equal sign that you're squaring is the one opposite the right angle. So if you put your finger on the right angle here, the side you're not touching, the C, is the one that's going to go alone. Important thing to remember, no matter what it's called. So if we apply the theorem, I'll show you how this works. We're going to have 6 squared plus 8 squared equals C squared. Now 6 squared is 36, 8 squared is 64, and so 36 will equal 36 plus 64 will equal C squared. If we add 36 and 64, we get 100. So C squared equals 100. And so C equals 10. So the length of the board would need to be about 10 feet long. Now notice in proving the theorem, we did not use the type of wood, the fact that it's made of wood instead of some other material, the dimensions of the gate, in what century it was built, and what continent. The only thing matters here is the geometry. So it's only the geometry of a situation that matters. So besides going to rectangles, if we had a square and we want to find the diagonal of a square, then I'll draw it there. Then we could use the lower right triangle and apply the Pythagorean theorem, because that's the essential geometry that matters. In fact, we don't even need a quadrilateral. If we've got any right triangle, like this, any right triangle in any orientation, could be this, then the Pythagorean theorem can apply. And to show you the letters don't matter, it's important to understand if we've got C, A, B, the important thing is that the two sides joined by the right angle symbol are the ones we add together after we square. So A squared plus C squared, in this case, would equal B squared. So don't get carried away by the letters. Make sure you're looking at the essentials, the fundamentals. Look at the triangle. Let me get the laser pointer. If we've got the right angle here, sorry the screen moved up and down, and we go across from it, we get the B. That's the one that goes alone. Whereas the A and the C that make up the right angle, they're the ones that go together. That's the important thing to remember. Now, another quick application of this, if you've got a post on the ground, could be something, flagpole, pole to do something else, pole to build a bridge, you want to put some support wires on it. We've got the same essential situation here. I'll do this in green also. If we have a support wire here, then we've got a situation where we can use a Pythagorean theorem. We've got, the screen went up again, sorry. We've got this leg here, and the hypotenuse. So we have a right triangle because the post or pole is at a right angle to the ground. So we can apply the Pythagorean theorem. And you'll be seeing this many other times in math. You'll be seeing this in your study of geometry and Algebra 2 and pre-calculus and calculus. And it comes up in physics and chemistry and building as well. With knowledge of this, you can make walls that are perpendicular to each other or a wall perpendicular to the ground anywhere. All you need is a 3, 4, 5 triangle or a 6, 8, 10 triangle or some other similar triangle that fits the Pythagorean theorem. So that is a brief lesson in the Pythagorean theorem today. We saw why it's useful, and we went over one quick, elegant proof to show you it's true. So, thank you very much for watching. Hope you learned a lot, and just let me know if you have any questions. Thank you. Bye.